Hello guys, welcome to the next lecture on the PY question series. Today I will explain you how you can solve the questions related to the Hilbert space. Myself Dr. Harish Garg. You can simply follow my YouTube channel. The channel name is Dr. Harish Garg. You can find it the playlist of the GATE mathematics, and you can see the last lecture was on the functional analysis. I recommended you kindly watch this lecture to understand deeply about the today's lecture. Apart from this, you can see the various PY question series is available in this playlist. You can learn it and crack the examination in a very simple manner. So what is the shortcut tricks for you? As I told you in my last lecture, whenever you are working on the Hilbert space or on the functional analysis, you must understand about the norm. And these are the standard examples of this. This is my L2 norm, this is my L1 norm, this is my infinity, and this is my LP norm. Make sure student, as I told you in my last lecture also, whenever you are working on the functional analysis, you must understand and remember these definitions of the norm in advance. Then only you can solve each question within the 10 to 15 second time period. If you are working on this continuous domain, then you can define the norm as here. Also, you can define, if I say norm of t, t is by any of the operator, fine. So then it is defined as supremum of tx divided by norm of x, and if norm of x is my 1, then instead of this you can say norm of t is my finite. If you prove that this is my here, then you can calculate, sorry, it's a supremum, then you can calculate the norm as a simple supremum of this value if my this condition hold. If you want to prove that any of the operator is bounded, then you have to prove this condition. If my norm of x is 1, then you can simply prove that this value should be less than of finite. Then it itself implies that it's a bounded linear operator. Now you must remember that there is a difference between the small LP and the capital LP. So the small LP is that summation of this should be the finite, and the capital LP is the integration of norm f mod of fp into d Lebesgue measure is a finite number. One tips is, remember always, whenever p is less than of the q, fine, then small lp is a subset of small lq, while capital LQ is a subset of the capital LP. Also, LP and this are called as the Hilbert space only when p is equal to 2. So these three tips are very useful for you to solve the PY questions easily. So let's start with the first one. LP is a Hilbert space if and only if, I already told you right now, it is only when p is equal to 2 is my right answer. Okay, look at this one. A is defined as a bounded linear operator on the complex Hilbert space. AX, norm of AX is norm of A star X, where A star is my adjoint of A. Then there exists non-zero X such that A is unitary, and here. What is the meaning of the unitary? So for the unitary, you need to prove that A into A star is A star into A. What is the meaning of the unitary? It's a unit, so it means it must be identity. Next one is a normal. How you can prove it's a normal? So that means you have to prove that A into A star is A star into A. Then the next one is the self-adjoint. How you can prove the self-adjoint? You can prove that AX into Y is Y into, sorry, it's a X into AY. It's a X into AY. Fine. Make sure if you prove that if the eigenvalues of lambda is not real, then it means A is not self-adjoint. Fine. Remember, this is only the necessary condition, but you can prove it as a counter examples. Now look at that. What is given to you? A star of x is 2 plus 3 iota times x. So unitary, I need to prove A into A star. So I can say, okay, as you remember my last lecture, so I can return this number is x comma 2 plus 3x by the standard product. So then what is the norm of the here? it should be the norm of 2 plus 3 iota. Fine. Now A star is my 2 plus 3 iota. What is my A? It's a complex, so it is 2 minus 3 iota. So what is the A into A star? So 4 plus 9, 13. What is the A star into A? Again, it's a 4 plus 9 is 13. Both are same, so it means it's a normal. It's a normal. Why it's not a unitary? Because it must be the 1, but it is not equal to 1, so it is not a unitary. So it is not a unitary, it's not a normal, but it's a normal, so this option is also cancelled. Now how you can check about the self-adjoint? So if you compare whatever the given to you here, fine. If I compare Ax is equal to lambda x, what is the meaning of that? Lambda is my 2 plus 3 iota is the eigenvalue of A star. So what is the eigenvalue of the A? Or you can see this eigenvalue is it a real? It is not real. So once this is not real, it means it is not self-adjoint. So the right answer is only D is my correct answer. Okay, look at this another one. Consider the Hilbert space L2, who is defined here. Inner product is my this and here. Okay, I can write this function as T of x. This function is x and it is my 1 over n. Fine. Now they are talking about the self-adjoint, unitary and here. So it means your target is to prove this thing. Okay, I can return this value in terms of here is summation x and it's a conjugate because the complex number, so 1 over n is my same, it's my 1 over n. Now I think it's a very simple. What is the definition of the self-adjoint is ax comma y is x comma ay. So I can start with the left hand side, ax comma y. So ax is summation x over n, y should be y. So if I again is an inner product, I can apply this definition again. So it's my x over n into y cap. Fine. This summation again it be adjusted here. If I look at the right hand side, so it will be it will be x comma here. So it is my x summation of y over n by using here. Then it will be my x into y over n bar. What is the complex conjugate of the n is my same. So you can see from here both are same. So it means yes, this is the self-adjoint. So neither the self-adjoint, both but not self-adjoint cancel. How you prove the unitary? So for the unitary you need to prove A star of this is my 1, but in this case it is not given as a E. That means T of T star is T star of T is my 1, but you can see it is not given to you. So I can give the another definition. If I prove is identity, so if I prove this here, then it means it is a unity. That's the same definition of this. So if I look at the right hand side, inner product is x of y cap. If I look about the left hand side, it is x over n, it is y over n. So again I apply this, it's a summation of x over n into y over n. You can see that, are they equal? They are not equal because here is the n square present. So they are not equal, it means it is not unity. So this option is cancelled, but it is not unity. So the D is my right answer of the problem. Okay, L2 space, capital L2, fine. So if I write the definition for here, what is the meaning of that? It's a B to A modulus of this into whatever it should be the finite number. Then which of the following is belongs or the, okay. What is the F1 is? T raised to power minus 1 over 3. So domain is my 0 to 1. I can apply this definition. It's a minus 2 over 3 into dt. It is my 1 over 3 and 1 over 3 from 0 to 1, which is a finite number. So if this is a finite number, it means F1 belongs to my L2. So neither F1 but not F2 cancel. Look at this one. F2 is my T raised to power minus 2 over 3. again I can apply this minus 4 over 3 into dt. So it is minus 1 over 3 divided by minus 1 over 3. So clearly say when you substitute as a 0, it is my not finite, because when you substitute infinity, it goes to the 0. So what does it mean? F2 does not belong to the L2 space. So that means A is my right answer of this problem. You need hardly a 15 to 20 seconds to solve this problem. I hope you can like and comment on the video as well. Okay, L2 space is again given to you. The usual inner product. What is the inner product is? What is the usual inner product is? That's the summation of x into y. Then is a Li. What is the meaning of the Li? Okay, if I simply prove un into um is my 1 if n is equal to m and 0 if n is not equal to m. Fine. What is the meaning of that? It is my Li or the basis. Fine. Now I can check it. So un into um, the domain is 0 to pi. So it is my 2 over pi sine nt sine m into t. Now clearly says this value will be my 0. Why? We all know by using the orthogonal properties of the sine and sine t. What is the un into m? So when m is equal to m, so it's a square. So when you square, 2 over pi is outside. So this is sine square n into t. So again, by using the orthogonal property, this value will be my pi over 2. So the answer is 1. Or you can solve this problem like of 1 minus cos 2 nt divided by 2 from 0 to pi. Again you will get the same answer. So it means this is a Li. It is not Li. Okay. Now once this property is satisfied, so what is the norm of the un? So I can return this number as un. So this value is my 1. So root of 1 is my 1. And what is the un dot It is my 0. What is meaning of that? If it is a 1, what does it mean? It's a orthonormal. Yes, it's a orthonormal. So, but he said it is not orthonormal. This option is also cancelled out. Now, look about the another one. The last two options. It's a orthonormal. Fine. It's a orthobasis, and it's a basis. What is the definition of the basis? Is if you take any element from the domain, from the space, fine, and you consider as a un is the part of this E. So if you write fi ui, if you take any of the function f from here, if you write in the terms of the un, fine, if you write where, sorry, it's not a fi, it's some constant alpha I into ui. So where ui is the part of this. So then if you write this f in the terms of this, then it's my basis, otherwise not. But you can see what is the L2 space. The last example suggested you this part belongs to my L2. Fine. So once this, can you write this function in terms of here? You can't write that because it is not, it is my here. So you can't write in terms of the sine and t. It means it is not basis. But he said orthogonal basis is a cancel, is a not a basis is the right answer of this problem. Okay, look at this another one. It's a orthonormal. So it means the norm of E is my 1. Consider the Hilbert space. So we all know I can consider the L2 is my Hilbert space for the easier calculation. So it's a small l. So what is the meaning of that is norm of this should be fine. Now, okay, so if I consider this is my x comma en, so it is n, so I can return here. Fine. Now since x belongs to my h, what does it mean? H is my L2, it means this value is my finite, where n varies from 1 to infinity. Now if I apply this here, what does it mean? If I start from the square, then it should be less than of, yes, it is less than of norm of x square, norm of en square by using the Cauchy-Schwarz inequality. This value is my 1 and it's a finite number, so it means this this is my yn, fine. This is my finite. What does it mean? It means this is my convergent. So what does it mean? That's a series. The series is convergent. So once the series is convergent, what is the meaning of that? The nth term, limit n approaches infinity, is my 0. But you can see he said does not exist. Cancel out is x, because x is my non-zero, so it is a non-zero. Is a 1, is a cancel. Only left option is my D, is my right answer. Because I chosen as a one particular example of the L2, so I can't say from this example this is the correct, but the rest of the options are discard, so that is a correct option. Okay, which of the following set is not orthogonal? It's not set the orthonormal. It's a orthogonal. What is the meaning of the orthogonal is? F1 dot F2 should be 0. Okay, if they are talking about the orthonormal, then you have to taken as F1 dot F2 should be 1. So I can start from the first one. What is the definition of the L2? It's from A to B. Now instead of the mode, it will be my F1 F2 into dx. Fine. Now look at the first one. Sine. Interval is minus pi to this. So sine nx. Second is sine mx. So what is the value of this? 0 by the orthogonal properties of the sine x. Fine. So you can see it's a 0, then it's a yes, it is a orthogonal, but we need a not. Similarly, if it is a cos, then it will be my cos nx is a cos mx. Again, is my 0 by the orthogonal property. So yes, it is a orthogonal. Third one is minus 1 to 1 x raised to power 2n plus half into x of 2m plus half. Fine. So I can return this number is x of 2 times n plus m plus 1 of dx. Now, can it be 0? What is this value? You can always see this number is my odd, always. So once this is odd, just like say x cube, x power 5, and minus 1 to 1 is my odd function, so it's my integration is 0. So the only left option is my here is the correct answer. But I can verify you whether this integration is 0 or not. So again it's from minus 1 to 1, x raised to power 2n plus 1, x raised to power 2m plus 1. So if I solve this, it is my x raised to power 2m plus 2m plus, so clearly say this is my even. So once this is even, the integration will not be 0. So it is a non-zero, it means it is my ortho, it's not orthogonal. So right answer is D is my correct answer. Okay, look at this. H is the complex Hilbert space. H star is my dual. Phi is defined like here. Which of the following linear, not linear, and here. Okay, firstly you can easily see it's a onto. Why? Why? You can see that phi of y is my fy. So I can return this is my x comma y. Fine. So what is the norm of phi? It is nothing but my norm of y. By which? By using the Rees representation theorem. So it means there exists a unique y. That is the definition of the Rees representation theorem, and that is the same thing I have explained in my last PY question of the functional analysis. So yes, this is my onto because there exists. So it is a onto. He said not onto, cancel, not onto, cancel. Now how you can check about the linear? So what is the meaning of the linear? Phi is a linear. You have to check the two property. This should be phi of y1 plus phi of y2, and phi of y1 is alpha times phi of y1. So let me firstly check this, always check about this property. So phi of alpha y, what is that? It is my alpha y. So if I apply this definition, it is my x comma alpha y. Now the space is my complex. So how I can take this number is outside. It is my alpha bar of x comma y. So this number I can return as f of yx, or this number I can return again by the definition of this is phi of y. But we need as a alpha, but it is my alpha conjugate. So it means it is my not linear. So once it is not linear, so first option is correct, the second option is discard. Okay, look at this another one. H is my Hilbert space, S complement, that means collection of all those y in the S such that their dot product should be 0 for all those, I can say collection of all those in the X such that this is in my of this. Now that's a very simple. If S1 is the subset of S2, then complement is my here. Fine. So look at that. The first property is the incorrect. First the right answer. S complement of complement is my S. So yes, this is the right answer. 0 complement. You can see I can return what is a 0 complement. It's a 0 comma y. Fine. It must be 0. So for what value of y, so that inner product will be 0. So for all those values of the y. Fine. You can take any value of the y, the inner product will be 0. So what does it mean? Y is the h. It means this value, that is 0 complement is nothing but my h. So it's a correct statement. But we need an incorrect statement. So this is a correct statement. I cross it. S is also the correct statement because S is my orthogonal complement is always close. So the incorrect statement is only A is the right answer. Okay, let H is the complex Hilbert space. Define here which of the following statement is my true. What is the meaning of this? Tx is equal to T. So how you can think about this constant? Okay, T star is the adjoint. T star is my adjoint of T. Fine. Okay. Fine. So what is the definition of the adjoint I have given you? That's if I written in the terms of the Tx, it is a Tx comma y is x comma Ty. This is the definition I have written you in my previous examples. Now if you look about that, what does it mean? T is the self adjoint of this. So this first definition is my self adjoint. That's a correct statement. So P is my correct statement. So in this case P is not there. So this is correct or wrong. What is the meaning of this? Okay, so if I look about this x comma Ty, if I write this expression, because this is my adjoint given, so I can return this value by using this definition is x, because this is adjoint, so I can return this number here. So that means T star of T star. So what is the T star of T star? It's my simple T. So you can see they are same of this x comma Ty and x comma Ty, which is same. So this is also the correct statement. This is also the correct statement. So P and Q are my correct statement. X Ty is equal to x T star y. What does it mean? It means T is equal to T star, but they are not given to you. They are simply say they are adjoint. It doesn't mean that T is equal to T star. It is it given? It is not given. So it means this is not always true. T of x is equal to Tx is my here. So again, if I apply the same concept here, it will be my x comma T star of y, which is equal to Tx Ty. Fine. Again, you can't say that if I apply again here, it will be my T star of s. So what is that? T star of T is T of T star. What is the meaning of that? It is a normal. But is it given that it's a normal? They are simply say they are adjoint. So not always correct that this is a normal. So this option is also cancelled. Only A is my correct answer. Okay, look at this another one. H is my Hilbert space. I can simply take L2. En is my orthonormal. So norm is my 1. It is given is a bounded operator. Which of the following cannot be true? So it means your target is to prove whether it's a bounded and the linear. So firstly check it's a bounded. How you can check about the bounded? Like for example, I can say this. Fine. So what is the tips I have given you? Whenever you have norm of x is my 1, then you just simply prove that this should be less than of finite. So E has 1. So what is the norm of this? What is the norm of this is 1, which is a finite. So this is a bounded. What is the norm of this? So you can see I can return this number as E of n and n plus 1. Fine. So what is the norm of this? It is same as of norm of this value. Fine. And clearly say 1 over this is my finite number. Fine. On the L2 is a finite number, so this is a bounded. So this is also bounded. Again, if you take as a norm, it's a 1, it's a bounded. If you take as a norm, again it's a bounded. So all are my bounded. Now you can check about whether they are linear or not. How you can prove about the linear? You can choose an E1. So that means your target is to prove E1 plus E2 must be of this. So look at the first example. What is the T of E1? Or what is that? This is my E1. What is the T of E2? Whatever the value of the n, it is my here. So the right hand side is 2 times of this. What is the left hand side? This is a single E1 because it is independent of this. So clearly say this number are not same. So it is not linear. So it means it is not true. Look about this one. It is a n plus 1. So definitely when you take E1 plus E2, it must be the next one. So that is a correct. So all others are my wrong. Only A is my right answer. Otherwise, you can simply choose n is my 2. Fine. And you can easily prove that all are my linear. But there is only one correct option. So I got as a E. Okay, which of the following is a Hilbert space? L2 square Tn is defined as here, pointwise and uniform. Okay, firstly I can check about the P statement. For the pointwise means we have to check about this case. If I prove that this is my finite, fine, then it is a bounded. And for the second case, it's a norm of this. For the Q case, I need to prove this should be less than of M. Fine. So firstly, okay, look at that. Firstly I can return this is my Tx. This is the product of x comma 1. Fine. Now it is on the L2. What is the norm of the L2 is? Summation of xi square. Fine. And over this is my L2 now. Now if I norm of this, if I apply Q firstly, what is the norm of this is? Norm of 1, and norm of the 1 on the this is root of summation 1. So what is the 1 square is 1. So it is my n. If you don't need a square root, so n, which is not finite. Fine, because as n approaches infinity, this will go to the infinity. So it means it is false statement. So if this is false statement, these are cancelled. Now look at the pointwise. So what is the mode of T and x? If I take the modulus, yes. So what is the modulus of this? It is my summation of xi, and we all know what is the x plus y modulus. It is less than of mod x plus mod y. So I can return this is summation of this, and this value I already given as finite. So it means this number is my finite. So P is my correct statement. So only P is my right answer of this problem. How many seconds you are needed? Just remember the definitions and the concept. Okay, look at this another one. Tn is orthonormal. So it means E of n is my 1. H is my Hilbert space. It is not given. So you can choose as a L2. Tn is defined here, then Tn minus T of this. Okay. Tn x, it is my summation of 1 by j x comma this into aj, and T of x is my 1 over n. Okay, same thing, the only difference is my here. So this is from 1 to infinity and this is from 1 to n. Can you find the value of Tn minus T? Look at that. This part is my 1 over 1, then 1 over 2 of this quantity, plus 1 over 3 this quantity up to 1 over n. And this value is when you substitute 1, then 2 of this, plus 1 over 3 this, and up to 1 over n plus 1 this, and so on. So if you subtract them, first n values will be cancelled out. The remaining part is only 1 by j x comma ej of j. So j start from n plus 1 to infinity. Fine. Now this is my t and x. Now let's start with this. Fine. It will be summation of 1 over j x comma ej of ej. Fine. Now on the L2 norm, so what is the norm of this is of here? Fine. Now I can return this by the what is the mode of by the Cauchy-Schwarz inequality. Now since this summation is from the j, so I can return this is my 1 over j. This is norm of x square, norm of ej square, and we know this value is my 1. Fine. This is independent of j, so I can take is outside. So it is norm of x square, which is 1 over j from n plus 1 to infinity. So clearly say when you take as n approaches infinity, this will goes to the, because this is the finite number, it will goes to the 0. Fine. So what does it means? That means Tn minus this will, because this is my convergent, sorry, it's a mode, it's a square, so it's my square. So once it's a square, it is my convergent. So once this is a convergent, so the nth term will goes to the 0. So that means if I clear this screen, it means Tn minus t definitely with respect to x will goes to the 0. So look at that. This will sorry, it is unbounded also. So this will not goes to the 0 is the wrong answer, and this goes to the 0. So first option is correct, this is wrong. And if again this, if Tn minus t is here, so again you can see this is not belongs is also the cross answer. Now the only thing you have to prove that whether it's a bounded or unbounded. So mode of norm of Tn is my here. Fine. So what is the norm of this? I can take a summation 1 over, what is the definition of this? Is a summation of x comma ej of ej. Fine. So again I can apply this summation part, it will be less than of norm of x, norm of ej is my 1, and it is my summation of 1 by j, where j varies from 1 to n. So clearly say this is my divergent. So once it's a divergent, it means this number is not finite. So once this is not finite, it means this is my unbounded. So once this is unbounded is also the correct statement of this problem. Another way you can think about like this also. I can write this expression as Tnx is x comma 1 over j. Fine. So norm of Tn is my 1 over j. Fine. J varies from 1 to n, so basically it's a 1 over n, and you know what over n is my divergent sequence, divergent series. So this is a divergent, so it is a unbounded. So A and C are the right answer. Okay, again it's orthonormal. So any element of the u is here, so norm of u is my 1 of this. Very simple. You have to find the maximum possible number of the elements. Let n be the number of the elements. So then what is given to you? This is my greater than of 1 by 4. So in order to apply the Cauchy-Schwarz inequality, I have to take the summation of this. But before that, I can take as a square so that I can apply the Cauchy-Schwarz inequality. This should be summation of 1 by 16. Now 1 by 16 is my n over 16 is less than or equal to this number. Fine. Now once this will be here, I can apply the Cauchy-Schwarz inequality. It is norm of x square, norm of u square. But u is my orthonormal, so this value is my 1. Norm of x is my 2, but we need a square, so this is less than or equal to 4. So n must be less than or equal to 64, and we need a maximum number. So what is that? This is the upper limit. So 64 is my right answer of this problem. Okay, look at this another one. E is the orthonormal. So that means norm of E must be 1. Norm of E1 is, I can take 1 as here. I can choose E2 is my this. Fine. Or you can choose any of the other. And is my Hilbert space. Okay. With the inner product, with the standard inner product, Fn is defined here. Which of the following satisfied the properties? Now all are working out for all n. For all n. I can choose n is my 1 firstly. Fine. So then what is the F1? Look at that F1. What is the F1 is? E1 minus 1 over 2 E2. Fine. Now how you can prove that this is orthogonal? It's not orthonormal. So what is the F2? So for the F2, because for the orthonormal you prove that F1 dot F2 should be 0. So what is the F2? It's a E2 1 over 3 E3. Fine. So I can take n is 1 for the other case. Let me firstly discuss here. So I can check about F1 comma F2. So it's a standard inner product. So what is that? E1 minus half E2 and E2 minus half E3. Now if I take E1 E2 is a 0 because they are the orthonormal. So it means EI into EJ is my 0. The first pair is my 0. E1 E3 0. E2 and E2 is a 1. So it is my minus half. And this number is again 0. So clearly say this number is my non-zero. So once they are non-zero, it means they are not orthogonal. But he said orthogonal. Fine. Now look at the other pairs. What you want to? F is 0 if now I can choose n is 1 firstly. So and F can be the any pair. So I can choose F is my E1. So what is the left hand side is F comma Fn. F is my E1 and it's F1. What is the F1 is? E1 F of E2. So if I open this, E1 of E1 is 1. This number E1 of E2 will be 0. So its answer is 1. Now F into En. So F is my E1. What is that? This is my n is my 1. So it is my E1. So which is 1. And you can see both are satisfied. But F is my E1. F is non-zero. But he said it's a 0 is also the wrong state. Now look about this. There does not exist a non-zero F. There does not exist a non-zero F such that F comma E2 is F of E2. Does not exist non-zero F. Does not exist. So can you think about any of the F? Okay, look at that. Very simple. If I choose F is my E1, so this left hand side is E1 comma E2, which is 0 by using the orthonormal, and the right hand side is E1. What is the E2? Sorry, what is the F2 is? E2 minus 1 over 3 E3, and you can see 0, 0. So it's satisfied, both are same, but there does not exist any non-zero. You can see it is a non-zero, that means there is a existence. So this option is also cancelled. Right option is the left behind is A is the right answer. Okay, H is my complex Hilbert space. Complex Hilbert space U and V such that norm of this might given. Okay, I can firstly think about here. This is U plus e raised to power iota v iota t, U plus e raised to power iota t into v. So I can open this bracket. U into U is norm of U square. U into this. Okay, whenever you have this over the complex plane, so it should be of this. Fine. Now look at that. What is the complement of this? E raised to power minus iota t into U, inner product of U and V, and it is given as a 2 plus, if I use here e raised to power iota t, and what is the norm of this? It is same as, because it's a symmetric, plus what is this property? Iota t U, iota t V. So I can take this as here, and this product is minus iota. So it will be u comma v, but here is a v comma v. So it's a v comma v is a norm. This value will be cancelled. So it's a norm of v square. What is the norm of u? It is not given. So I assume norm is my say a, norm of v is my b. So this expression will be a plus b plus 2 times e raised to power minus iota plus e raised to power iota. That's over. I can substitute here and then integrate from 0 to 2 pi, multiply by e raised to power iota t plus 2 times 1 e raised to power 2 iota t. Now you can integrate them. Once you integrate this, a plus b is a constant. It's a e raised to power iota t over iota from 0 to 2 pi plus 1 integration is t. It's my 2 iota t over 2 iota from 0 to 2 pi. Now clearly say this value will be 0 because it's a 2 pi iota e raised to power 1 over iota. This value is my 0. Again, this value is e raised to power 4 pi iota minus 1. This value is also 0. The only remaining is my 4 pi. And if you divide it by 2 pi, answer is 2. Look at this another one. Again, it's a orthonormal. Norm of this is my 1 and ei, ej will be 0 if I is not equal to j. Then there exists a boundary. Okay, Hilbert space is not given, so I can assume it's a L square. Fine, always choose as a L square. There exists a bounded and here f of en. Can I write this function as en of 1 over n? Because norm of en is my 1. So what does it means? Norm of f is norm of this by Rees representation theorem. Or if you don't remember this, you can watch my previous lecture on the functional analysis, that is this one. This one. You can watch this lecture, you will learn this concept. Then, and if I, what is the L2 is? It's a 1 over, if I write this quantity, what is the L2 is? Xi square, it should be finite. So if I use here, it will be 1 over n square. And you can see this is my convergent series by the p test. Fine. So if it is a convergent, so the sum will be finite. So it satisfied this, it means it is my bounded and it's a linear. So it's a bounded, yes. Linear, clearly say it's a linear because it's a 1 by n. Again, for this g, I can write this function as e of n 1 by root n. So norm of g is my norm of 1 by root n. So again, it's from the L2. I can return this is summation of 1 over n square. So clearly, sorry, it's a 1 over n because root will be cancelled out. So it will be 1 over n. And clearly say this is my divergent series. So once this is divergent, it can never be finite number. So it means it is it bounded? No, it is not bounded. But he said it's a bounded, so this option is cancelled. Only P is my correct answer of this problem. A very simple approach. Always represent the function in this manner. Okay, look at this one. Again, this is orthonormal. So norm of ek should be 1 and ek comma ej will be 0. Define this off here. Now look at that. Here summation is start from the k. So what is the value of the j? J, I can choose the value of the j as my own convenience. If I choose j is my 1, what are my options? This is 1, it is 4, it is 1. We get two same options. So I can change the value of the j. If I choose j is my 2, what is that? It's a 0, it is my 4, it is my 1, it is my 16. So now all are different. So let's say 2. So k and g. Okay, so what is the g of 2? Fine. So j is 2. So minus 1 of n plus 1 e of n. So if I substitute 1, it is my e1 minus e2. Fine. Now if I substitute here, k is 1, so j is my 2, so it's a g2 comma f1 square plus g2 f2 square plus g2 f3 square and so on. That's over. Now I can substitute this value. What is the g2? e1 minus e2. What is the f1? I can find f1 from here. It is e1 plus e2 non-square plus e1 minus e2. f2 will be e2 plus e3 plus e1 minus e2, e3 plus e4 and so on. So if I look about this one, the inner product is a 0 because of this property. e1 e4 0, e2 e3 0 is a 0. So this component is 0. Similarly, less components are 0. This value will be e1. Norm of e1 is my 1. e1 e2 is a 0. This is 0. This is my 1 plus this is 0. This is 0. This value will be my minus 1 and this number is 0 of whole square. So what is the right answer? 0 plus 1 is my 1 is the right answer. So it's a 4, 16, only D option is my correct answer for this problem. Okay, look at this another one. Okay, as I told you, whenever P is less than of the Q, small LP is the subset of the here, capital LQ is the subset of LP. So this is my yes correct statement, but this is my wrong statement. So only one is my correct answer. Which of the following statements are my true? Again, you can see 3 is less than 7. So and the small L3 is the subset of small L7. So this option is cancelled out. Now for this 6 is less than of the 9. Capital L9 is the subset of capital L6. So this option is correct. This option is wrong. Now look at this another one. Now you will see it's an orthogonal projection. Fine. So always remember this is the shortcut tricks. Whenever you want to find the projection of the vector V on the U, so remember V on the U. So that quantity you have written in the denominator and the inner product of this one. Now you can see about how you can solve this question. I need a P, okay, given that PG is the orthogonal projection of G on V, but my target is to find G minus PX. So G minus PG is the orthogonal projection. I can subtract them, it's a projection of V complement. Fine. So it means if I consider, I need to find the projection of G. So I need to find projection of G on V complement. So what is the answer of this G? What is the element of the V complement? Element of the V complement is my F divided by FF into F by using here element V comma U divided by norm of U and into V. Now I can calculate what is the definition of the L2. L2 means 0 to 1 F. If they are the different element, then it's a F into G. Fine. Now what is the right answer of this? On this numerator part, domain is my 0 to 1 F into G. So it's my x cube into dx divided by F if into F x square. F will be my single x. So what is the answer of this? Is a x4. So that's a 1 over 4. It is x cube 1 over 3 into x. So right answer is 3 over 4 into x is my right answer. You can also discard the third and the fourth directly because my target is on the V complement. So what is the V complement is F. So it means it must be written as a F. But here is it is not a F. So that's why C and D directly cancel. Look at this is a recent year question. Again your target is to find the orthogonal projection of this onto the M complement. Fine. So look at that. What is the M complement? Firstly, what is the definition of this? Collection of all those elements such that x dot y should be 0. So if I write this value, can I write this quantity as xn of 1 by 4n? Fine. Collection of all those x. I can return this function. There is no issue about that. Now, it means my projection of this, if I consider this is my u, so my projection of u on m complement. So what is the m complement? This is my m complement. So my target is to find on this divided by 1 over 4n, 1 over 4n into 1 over 4. Fine. U on this. Now what is the inner product is? This is my inner product. So how you can write that? I can return this u. So what is the basically u? U is basically my 1 over n. Fine. Now I can substitute here. This is the inner product of 1 over n, 1 over 4 is to power n divided by, can you find the norm of this? What is the space is? L2 space, and norm is defined like here. So it is summation of xn, because they are the same value. So what is that? It is nothing but norm of this. It is 1 over 4n square, and this 1 by root 2 is a cancel out of this square, because we all know inner product of this is basically a norm of square. So norm of square is my here into 1 over 4n. So I need to calculate the denominator part. What is that? It is 1 over 16n, and n varies from 1 to infinity. This is my GP. So what is the sum of the GP? A 1 over r. So it will be my 15. So the right answer is, I can write here. So the numerator part will be 1 by n. What is that? It will be, is a inner product. So the space will be my 1 over n into 4n into 1 over 4n, and it is my 15. 16 will be cancelled. So this is the right answer of this. And if you compare them, you can see it's a summation of 1 over n. This is my 1 over 4n. So alpha will be my 15 is the right answer. Look at this another one. Again, your target is to find the best approximation. Best approximation means you have to find the projection. Okay. Firstly, you can see about here. My target is to x complement. I can return this function is t square into x will be 0. Fine. It is quite obvious. Now, what does it mean? T square belongs to my x complement. Fine. Then the best approximation of the y. So means my target is to find the projection of y. What is the y is? T cube on elements of this. So how I can write that? It's a y comma t square divided by norm or inner product of this into t square. So we can see firstly it's all a t square. So I can simplify this. What is the definition of this here? So it's the integration from 0 to 1 y. What is the y is? T cube. So it is my t raised to power 5 into dt divided by t raised to power 4 into dt. Fine. So what is the integration of this is? 1 over 6. Integration of this is 1 over 5. So the answer is 5 over 6. So the answer of this is 5 over 6 into t square. That's a B is my correct answer. It's a 2021. Again, whenever you have to find is the infimum of something. Fine. That means you have to find the projection of G on the F. Always remember, whenever you find the distance between them, the easiest way is you can find the projection of G on the F. Okay, so what is the G? If you look about element of the M, if I look about this quantity is F comma 1, it is a 0. I can return this value. So what does it mean? This is my elements of the M. So what is the projection of this is? I can return this quantity as F is my x square comma 1 divided by, sorry. So how you can return that? Projection of, okay, so it will be x square. So F is my x square. Fine. Other value will be my 1. If I call this is my say h. So my target is to find the projection of this on 1. So what is the inner product is x square into 1 over 1 comma 1 into 1. So what is the inner product is the denominator is my norm of 1, fine, and this is my inner product. So what is the definition of this here? It is my 1 2 minus 1 square. 1 square is my 1 into dx, and it is my norm square, fine. So norm square will be, so what is the denominator part is, it's my 2, fine. Now what is the numerator part? It's the integration of 1 to minus 1. It's a, now since it's a norm, so if you convert into these are the different values, so I can use minus 1 to 1 f into g, so it will be my x square, fine. So what is the integration of this is an even function, so it is my 2 over 3. Is it fine? Now what is the 1 comma 1 is, also it's a norm, is already given that it's a norm, so it's my root of this, so 2 by 3. So what is the right answer of this? It's a 2 over root 3. So first is my right answer of this problem. Okay, consider this one as a real Hilbert space. You can consider H is my L2, P is non-zero, this, then the orthogonal projection of Q on the G. So if you see about here, so the element is my X is a part of the H, so I means find the projection of G on P. So how you write that? Q into P divided by P of P into P. Then the orthogonal projection of Q onto the G, fine. So you can subtract the initial value, fine. So this is a Q minus A. B is my right answer, because this norm of P comma P I can written as norm of P. Look at this another one. Again your target is to find the projection of Q onto G. So what is that? I can find the element of the G. So G is my here. This value again I can return function of the f firstly. Next part is my x. It is my 0. So my target is to find the projection of the Q on the x. But he said is find the projection of this orthogonal projection of Q on the G. Fine. So my target is to find Q minus this over x comma x into x. So what is my Q? Is x square. The first element is already x square. So I need to compute only this value because x is already written here. So what is the norm of Q comma x? I can substitute here. It's a L2. Sorry, it's a L2. What is the norm of the L2? 0 to 1 f into g of dx. So the numerator part is Q is my x square. So x square into x from 0 to 1. So it's x cube is my 1 over 4. Clear? Now denominator is x of x. Again I can substitute here. It is my x square. So the integration of the x square is 1 over 3. So ratio will be 3 over 4. So my right answer is wrong. 3 over 4. A is my right answer. Rest options are cancelled. So I hope you can easily learn many shortcut tricks here. I hope you can like and comment on the video as well. We will see the next lecture on the real analysis PY questions from the GATE examination. Till then, you can simply like, share and comment on video. Best of luck students. Happy learning.